This video is going to discuss several features of functions, including minimums, maximums, discontinuities, and asymptotes. First, let's talk about minimums and maximums. Minimums are lowest points on the graph, while maximums are high points on the graph. Both minimums and maximums can be labeled as relative mins or maxes, or absolute mins or maxes. Let's look at graph 1 to see some examples. Looking at graph 1, I see two low points on the graph. Right here at -3, and here right around +2. These are both lower than any points nearby. However, one of them is lower than another one. We would call this at 2 a relative minimum, because relative to the other points in its region, it is a minimum, but it is not the lowest point on the entire graph. Therefore, over here at -3, we would call this an absolute minimum, because it is the absolute smallest point on the graph. Looking at maximums, I see one kind of bump here. Now this one is the only maximum, but it's also a relative max because it's not the highest point on the graph. You see these arrows mean that those will go up forever, so it wouldn't be the highest point. All right, let's look at example 2 here, where we also see that the points have already been labeled for us. So minimums, or lower points, would be -1, -3, and 4, -1. And this is an appropriate way to label them with actually their coordinate points. You'll notice that -1, -3 is lower on the graph than 4, -1. However, these are both going to be relative minimums because this arrow to the left means that that's going to go down forever, so there's no absolute minimum. You'll notice the same thing's going to happen with the maximums because on the right, the arrow goes up forever. So we have two relative maximums. Now let's look over at number 3. Number 3 is kind of a weird looking graph. I'm not seeing any of these bumps that sort of gave us our mins and maxes. And I'll notice that on the left, the arrow goes up forever. It doesn't look like we have a maximum, so there's no maxes here. Now this arrow on the right is going to keep going down forever. It's never actually going to go below 0, and we'll talk about asymptotes in a second, but it is going to go down forever, so there's also no minimum. So it's entirely possible that a graph could have no maxes or no mins. Another important thing to note about maximums and minimums is it's where the graph changes from increasing to decreasing. Next, we'll talk about asymptotes. Asymptotes are lines that the graph approaches but never reaches, and they can be both horizontal or vertical. They're actually sometimes drawn in on the graph as well, which can be a little confusing. Sometimes they'll be drawn in as a horizontal or vertical line, or sometimes they'll be drawn in as a dashed line, and sometimes they're not, so they can be a little bit difficult to identify. But let's look at number 1, graph number 1. We've already seen this graph. We're going up forever to the left, but looking as we go towards the right, as x gets really big, we're supposed to assume that the graph is going to creep closer and closer to that horizontal line, y = 0, but never actually hit it. So again, we sort of have to assume that, but generally it's a little clearer. So we would say the asymptote here is y = 0, because that's the name of that line that the graph's never going to hit. Looking at number 2 now, you can see on the right, it's going to go up forever, up and to the right. But over on the left of the graph, we're getting closer and closer to that y-axis. So that's actually a vertical asymptote at x = 0. Number 3 is probably the easiest one to identify, and we have a lot of different asymptotes going on. This red line here is indicating that we have a horizontal asymptote at y equals 1. And these two blue lines, these two blue vertical lines, are indicating that we have two vertical asymptotes at x equals -1 and x equals +1. So we name asymptotes by the equation that would give their line. So horizontal lines always start with y equals, and vertical lines always start with x equals. The last feature we'll look at here are discontinuities. Discontinuities can take 3 different forms. We can have something called a jump discontinuity. We can have a hole, also known as a removable discontinuity, or we can have an asymptote, meaning a vertical asymptote. Now, continuous functions can be drawn completely without picking up your pencil. So looking at graph 1, if I put my marker down over on my left arrow, I could draw the entire graph without picking up my marker. If you look at an extreme example over like graph 4, you can see if I put my marker down on 1, once I get to 3, I'm going to have to pick up my marker, tap it once, then go all the way back down, then go up. At 8, I'm going to have to pick up my marker again to draw the rest. These places where you have to pick up your marker are called discontinuities. So in example 4, we have a discontinuity at 3, x equals 3, and a discontinuity at x equals 8. And they're usually identified by their x value. So we would say at x equals 3, there's a discontinuity, and at x equals 8. And these are actually both examples of jump discontinuities. There's actually a break in the graph, and then we pick it up again at a different y value. We were here at y equals 3, and then we jumped up to y equals 6. Going back, let's go over to graph number 3. You can see again at x equals 2, I'm going to need to pick up my marker and kind of jump over that hole. Even though I just used the word jump, this is actually called a hole because we're not changing y values. We just have kind of an empty hole that we need to skip over. So this is a hole or removable discontinuity. We've already discussed that graph 1 is continuous, so there are no discontinuities there. In graph 2, you'll notice if I start drawing my graph, eventually I'm going to hit this vertical asymptote at x equals -1, that if I ever want to get to the other side of, I'll need to actually pick up my marker. So my discontinuity is there at that vertical asymptote, -1, and then I have another one at x equals 1. We'll discuss more in the future what causes these discontinuities, but for now, I just want you to be able to identify them from the graph and know that we identify them by their x value. And these were asymptotes. Here's a quick summary of what we've looked at. We looked at minimums and maximums, and we said that they could be either relative or absolute. And we said that we want to identify them by their coordinate, their x, y. Then we looked at asymptotes, and we said they could be horizontal or vertical. And we want to identify them by the equation that gives the line. So if it's horizontal, it'll be y equals something, and if it's vertical, it will be x equals something. And then last, we looked at discontinuities, and we said there were 3 different kinds: holes, vertical asymptotes, or jumps, but they're all going to be identified by their x value, like x equals 1.